All right, so here we go. We are live right now. I hope I'm audible to all of you. Great. So, welcome back. Welcome back, all of you, to this amazing platform of Tutee Learning JEE. So, today we're going to discuss our ongoing topic of family of circles, right? So, we have been discussing circles for quite a long time now, and now, all as we are approaching towards the end of this particular chapter. So, in today's class, we're going to be rewinding some of the basic concepts that we have studied so far in this chapter, and along with that we're going to understand this particular concept of family of circles. And after we finish off with the family of circles, we're going to solve some miscellaneous questions, right? So those questions are going to be directly from the JEE Mains and advanced previous year questions, and we're going to definitely see that how we will be solving those questions and what are the different techniques behind solving those questions, right? So let's get started. So I hope you have watched the previous lecture before you are coming to watch this particular lecture, because if you haven't watched the previous lecture, you won't be able to get the continuous or the continuity of this particular chapter, right? So it is always necessary to have a continuity by watching the previous lectures, okay? And then we start to discuss about today's topic. All right, so let's get started. So as we have seen that we have been discussing with the family of circles, and what we have understood is that the family of circles is basically the set of all such equation of circle which is basically following certain criteria or conditions, right? So we looked into first of the condition that when we have two circles which are intersecting at 2 points, then if I want to find out or generate all sort of sets of circles which is basically intersecting or passing through this particular point of intersection of those two given circles, then that particular equation of the circles I can easily write in form of this particular notation, right? So that's what we have seen in our last class, that is given as S1 plus lambda times of S2 equals to 0. And similarly, we can also have another sort of circle, that is when there is a circle and a line equation is given such that this circle is intersected, the circle is intersected at 2 points A and B, right? So if I want to generate another set of family of circle which is passing through this point of intersection A and B with this line in the circle S, then that can also be generated simply using this concept, that is S plus lambda times of L equals to 0, where please note that the lambda is our variable or the parameter. So depending on the different values of lambda or the parameter, we can generate multiple sets of family of such circles, right? I hope this is clear to all of you. All right. So if you have any question, any confusion, please do let me know in the live chat. Okay. I will try my best to answer to your live chat. All right. Okay. So today we're going to discuss about another possible, all the such possible conditions of family of circles, right? So let us get started. So what we have observed that along with the previous two cases of family of circles, we can also have some other cases as follows, that we can have the equation of the family of circle which is touching the circle at a particular point. Now in the previous case what we have seen is that, so over here what we have seen that this circle is being intersected by this line AB at 2 points. So instead of 2 points, if I just change this condition and say that the circle is intersecting this particular line at a particular point, that is, it's becoming like a tangent. So let us say this is a center, let us say this is S, and the circle equation is given as S equals to 0, right? Now I hope you are very much familiar with this expression, that is S equal to 0, that is the equation of circle that is given as x square plus y square plus 2 times of gx plus 2 times of fy plus c equals to 0, right? This is what the expression S equals to 0 actually means. So this is the equation of the circle. Okay. Now and let us say this tangent equation is given as L equals to 0, which means this L is basically the equation of the straight line, that is basically given as ax plus by plus some, let us say c dash equals to 0. Okay, so that I have the distinguish the constants of the circles and the line equation. Okay, so I should distinguish this particular constant c and c dash. Okay, so and what I can say is that if I just want to find out all sort of sets of equation of circles such that which is also touching this particular line at this particular point, let us call this point as point P, or the point of contact of the tangent of the circle S equals to 0. So if I want to generate this all possible sort of equations of this family of circles, that can also be simply given as equation of this family of circles can be given as S plus lambda times of L equals to 0. So which is again the L is the parameter. So which is very similar to the previous form as we have seen, right? So this is the another form of modification in the family of circles what we can also have. Now another set of possible modification that we can have in the family of circles, that is, if I say that the 2 points, instead of giving you the circle equation, if I give you the diametrically opposite points of circle, let us say the diametrically opposite point of the circle is given as P and Q, which is basically coordinates are x1, y1 and x2, y2, such that this PQ is passing to the center C. Okay, this is capital C. Now, if I want to generate the equation of family of circle, which is again passing through these 2 points of context P and Q, then that can also be written in form of, so something like, if I want to generate another circle which is passing through this point P and Q, something like this. So this sort of family of circles, so this sort of equation of this family of circles can be given as, now we have understood and we have already seen in our previous discussion that when the diametrically opposite points of a circle is given to us, we can easily write the circle equation in the form as x minus x1 multiplied with x minus x2 plus y minus y1 multiplied with y minus y2, and that is equal to 0. So that is the equation of the circle. Along with that, using these 2 points of contact, this P and Q, we can also generate the equation of the line. So this equation of the line can also be generated using this point x1, y1 and x2, y2, which I can write in form of some determinants, that is x, y1, x1, y1, 1 and x2, y2, 1, and this determinant should be equal to 0. So if you recall, this is nothing but the area of the triangle equals to 0. That means that if I take up any point x, y, these 3 points are to be collinear, right? So therefore, if the collinearity is satisfied, that means they are lying on the same straight line PQ, then therefore this particular determinant should be equals to 0. So which actually implies that this is the equation of this particular line. So using this particular way also, we can also write the family of equation as S plus lambda times of L equals to 0, right? So which is going to look like something like x minus x1 into x minus x2 plus y minus y1 into y minus y2 and plus lambda times of mod of x y1 x1 y1 1, and then we can have x2 y2 1, and that should be equal to 0. So this is our family of such particular equation of circles. Okay, and here the lambda is the parameter. So depending on the different values of lambda, we can generate all possible set of circles. Okay, is this part clear to all of you? Is this part clear? All right, so now, and along with this, we can also have further modification to this particular thing by saying that if instead of giving you this this way of writing the equation of the line, we can also do one more modification and write the equation of the line as x minus x1 times m, which is the slope, plus y minus y1. So this should be given as some like y minus y1 should be equals to, so this can also be given as y minus y1 should be equals to m times of x minus x1, right? This is also how we can write the equation of straight line. So we can also find out the slope and we can also write down the equation of the line as well, right? So these are the different sort of modification we can also make into our given condition, right? So these are the all sets of family of circles equation that you need to take in mind for solving questions, right? Now apart from this, there are certain more cases to also consider, that if we give another case, something like, let us say I give you the triangle, I give you all the 3 sides of the triangle. Let us say this is my A, B and C, and all the 3 sides of the triangle are something given as like L1 equals to 0, L2 equals to 0 and L3 equals to 0. So these are the 3 sets of equation of the line of the sides of the triangle, right? Now if I want to find out the equation of the circumference or circumcircle of this particular triangle ABC, of the circle passing these 3 points ABC, that also we can easily do. And in a similar manner, we can take up any set of quadratic polygons, or maybe like quadrilaterals, pentagons, and such that we know all the equation of the straight lines of the sides, right? So in the similar manner, if I give you a quadrilateral like this, and if I ask you for the equation of the circumcircle of this particular quadrilateral, right? Something like this. So this equation of the quadrilateral, then that also I can do easily. The simple way to write down this particular form of such sort of equation of this family of circle circumscribing, okay, circumscribing this triangle or this quadrilateral or any sorts of polygon. Okay, so I'm writing over here polygons, okay, whose side equation are given as L1 equals to 0, L2 equals to 0, and so on up to Ln equals to 0, right? So this Ln denotes the nth side of that particular polygon. Okay, so Ln equals to 0 is basically that particular side of the, or the equation of that particular side, right? So if I need to generate for that particular equation, that is simply given as L1 L2 plus lambda times of L2 L3 plus mu times of L3 L1 plus other sort of variables, and we can generate all possible sort of combination of this product, and that should be equal to 0. Please make sure that when you are doing this particular product, you have to take care of one of the condition, that is because you are having multiple variables. So instead of having only one variable or one parameter, we are having multiple parameter this time, right? So these are lambda, mu, and such parameters will be present, right? So please make sure that the coefficient of x squared should be equals to the coefficient of y square, right? Should be equals to the coefficient of y square, right? This is the first condition, and the second condition is that the coefficient of xy should be equals to 0. Okay, so please make sure to ensure that these two particular guiding principle or this condition is satisfied. Okay, so if you are able to satisfy this sorts of condition, then you will be able to generate the family of circles circumscribing any polygon. So in case of in this particular circumscribing this triangle, we can generate that is L1 L2 plus lambda times of L2 L3 plus some mu times of L3 L1 is equal to 0. Similarly, in terms of this quadrilateral, we can also do some modification, and we can write this equation as L1 L3 plus lambda times of L2 L4 should be equal to 0, right? So this is the equation of the family of circles circumscribing the quadrilateral. Okay, I hope this is clear to all of you. Alright, so these are some of the additional parameters which you need to also keep in mind. Maybe some sort of question you will be able to apply this, right? But what I would suggest is that you have to take care of the general and the basic concepts, right? So please make sure that you know all the basic concepts, right? Because sometimes it might happen that you forget all of this, but still you have to answer this particular question, right? So therefore, it is always essential to state the question and start from the very basic. I hope this is clear to all of you. If you have any question, do let me know in the live chat. All right. Is this part clear to all of you? Is this part clear? Okay, so now we can proceed to solve some of the miscellaneous questions, and with that we'll be officially ending this particular chapter of circles, right? So let us take up some problems so that we can understand how to solve question in our actual JEE Mains paper. Okay, so I'm taking up some of the previous JEE Mains question itself, okay, and I think you will be pretty much easily able to solve those questions. Okay, so please try it up. Okay, so the question is on your screen, so please try it up once. So please try to solve this problem. So try to solve this problem. Okay, so once you're able to solve this problem, then we can discuss about the solution. Okay, maybe you can also let me know the answer you are getting in the live chat. Is it clear to all of you? Is this part clear? Okay, so let us try to see what this question has to offer. Okay, so if we look into the question over here, what we can see is that it is saying that if the circle, this particular equation is circle, and this particular equation is circle cuts in 2 points A and B, then you have to find the equation of this particular circle whose diameter is AB, right? So it is again a question of family of circle. Now you must be wondering, how is this a question of family of circle? Now most of you must be solving this question by solution of these two equations. So you must be solving this first circle equation with the second circle equation to get out the points A and B, and from there you will be able to get the coordinates of A and B, and then you can easily generate the circle with the endpoints or the diametrically endpoints, right? However, if you try to think of this problem, what is mentioned in the problem is that if this is my first circle, which is basically, let us call this expression S1 equals to 0, and another circle like this, which is basically the second expression, which is S2 equals to 0. Now it is saying that if these circles are intersecting at point A and point B, we have to generate another circle like this. Now this is the circle we require, right, whose diameter is basically A and B, right? So this is how we will try to solve the problem. So instead of solving for this point A and B, we will try to generate such set of family of circle equations which is passing to this point A and B, right? So this required circle will have the equation of the form S1 plus lambda times of S2 equals to 0, where lambda is our parameter. Okay, so lambda is our real parameter. All right, now, and also since A and B are the diametrically opposite points or at the diameter, then we can also apply one more condition, is that this AB line is going to be the equation of the common chord, right? For these two circles, it is the equation of the common chord, right? So we can also approach this problem by finding out the equation of A and B as the equation of the common chord is given as S1 minus S2 equals to 0, right? So instead of doing it S1 plus lambda times of S2 equals to 0, we can also approach this problem as, since this is the equation of that common chord, we can also approach this question as S1 plus lambda times of L equals to 0, right? So these are the two different ways of writing the same set of circle, right? And also once we get this straight line AB, right? So once we get the straight line AB, now what we can also conclude is that since AB is the diameter, therefore the center will lie definitely inside on the line AB, right? So once we get this line equation, and from here once we get the center, then we can solve in this particular equation to get to this value of lambda. So let us try to do that, right? Or maybe we can also go by this particular approach as well. From here also we can find the center and satisfy the equation of the line AB, right? So let me first of all find the equation of the line AB. So if I try to find out the equation of the line AB, then that can be given as S1 minus S2 equals to 0, and that can be given as 2x plus of 1 equals to 0, 2x plus of 1 equals to 0, right? And therefore the equation of this required circle can be also generated as x square plus y square plus 2x plus 3y plus of 1 plus lambda times of 2x plus of 1 equals to 0, where lambda is our variable parameter. Now from here you will try to obtain the center of the circle. So this I can write as 2x lambda plus 1 plus 3y plus lambda plus 1 equals to 0. So from here the center, the coordinate of the center of the circle will be given as, so we can get the center of this coordinate of the circle is basically given as lambda plus 1 minus lambda plus 1 comma minus 3 by 2, right? That will be the center of this circle. Now the center will definitely lie on this line AB. So if we solve for this particular coordinate with this equation of the line AB, right, with this equation of the line AB, we will be easily obtaining the value of lambda, right? So that is basically going to be 2 lambda plus 2, and minus sign will be outside, and that plus 1 equals to 0. So from here the value of lambda should turn out to be negative 1 upon, right? So from here we will get the value of lambda to be negative 1 upon 2, and therefore our required equation of the circle will be simply given as, so x square plus y square plus x plus 3y plus half equals to 0. So that is the required equation of the circle. Is this part clear to all of you? So this was what was basically being asked in the problem. Okay, now please make sure that when you are choosing the correct option for your answer, please don't hurry, because sometimes the option will be basically giving you the entire equation of this circle, right? Now I have seen students, they basically misunderstood because the first two terms of that, all the four options are almost similar, right? So they go on hurry and make some mistakes in this plus or this minus sign, right? So please be sure that whenever you are choosing the sign or the option, please cross check or check it with whatever you are obtaining with this given answer. Okay. All right. So that is the very important tip that you need to keep in mind when you are going forward for your actual examinations. Okay. I hope this is clear to all of you. I hope this is clear. Is this part clear? Yes or no? Is this part clear to all of you? All right. So let us try to see some more problems in order to understand and our given discussion of family of circles. Okay. So we will try to solve some more problems to actually understand, and so that you are ready to actually go on and solve some of the JEE Mains questions. Okay. And also whenever you are solving exam problems, you will be seeing that these are the very types of questions that you have already practiced in the classes. Okay. So this is the second problem that you must try. Okay. So if you read it in the question, it is again problem formulation is again that very similar to that of the family of circles, right? So it is asking you for the equation of the smallest circle. Okay. So it is asking you for the equation of the smallest circle which is passing through the intersection of the line and the circle. So here we have to find out the value of this parameter lambda such that the circle is basically is the smallest circle, right? So the smallest circle, there is a catch over here that the smallest circle will be the smallest circle if and only if the circle or the center of the circle is lying on the chord or the intersection of this particular line. Okay. So if I try to explain you this particular thing, so if we have this particular circle and it is saying that this the passing to the intersection of these two lines, right? So like this, so the circle is going to be the smallest circle if this particular chord, that is, let us call this line AB, that's the chord AB. So this circle must lie as the diameter should be AB, right? So this is going to be the smallest circle. Okay. This is going to be the smallest circle. All right. So our equation of the line AB is given as x plus y equals to 1. That means the center of this generated circle should lie on the line AB, right? So please try to find out s plus lambda times of L equals to 0, and from here, once you get the center and try to satisfy this equation of this line AB, and from there you can easily obtain the smallest circle. Okay, so I leave it up to you to try and let me know the final answer. So do let me know the final answer. Okay, so try it up and tell me the final answer you're having. Krishak, Mittal, yes. Tell me the answer. So please tell me the answer you are getting. All right. So if you try to find out this equation in the family of lines, what you will obtain is something like this. That is x square plus y square plus lambda times of x plus y minus 1 minus of 9 should be equals to 0, right? So from here, the center will be something as minus lambda by 2 comma minus lambda by 2, right? And this should lie in this particular equation of the line AB. So from here, I will obtain lambda by 2 minus lambda by 2 minus lambda by 2 should be equals to 1, which will basically give me lambda should turn out to be minus of 1, right? Lambda should turn out to be minus of 1. So once we get the value of lambda, we can put it over here, and that will requiredly satisfy the equation of the smallest circle. Okay. I hope this is clear to all of you. Are you all able to get the answer minus 1 as lambda? Is it clear? Is it clear to all of you? Okay. So I am assuming this is clear and you are able to get to the answer. So let us now move forward to solve some more problems, okay, which are quite an useful problems. So the next problem that I'm trying to give it to you is this one. All right. So here, now this problem is going to be a good problem, right? So here it is mentioned that you have been given three sets of circles, right? C1, C2 and C3. So it is mentioned that C1, C2 are the circles of unit radius whose centers are given as 0, 0 and 1, 1, and C3 is a circle of unit radius passing through the centers of these two circles. Okay, passing through the centers of this circle C1 and C2 and have the center above the x-axis. Find the equation of the common tangent to C1 and C2 which does not pass through C1 and C3 which does not pass through C2. Right. So it's a wonderful question. Let us try to visualize the geometry of this. Okay. So if we try to visualize the geometry of this question in order to understand or solve this problem. So the question is something like this, that you have our coordinate equations over here. Let us say this is the x and y axis, and let us say we have some circle C over here which is C1, which is the center as origin, right? And we'll have another circle whose center is 1, 0, so it will pass through origin, right? This is basically C2, this is C1, 0, 0, and we have another circle which is C3, which is having its center at somewhere above the x-axis, and it is passing the centers of these two circles, okay, that is C1 and C2. All right, so this is how the circle is looking like. So this is basically a C3 somewhere over here, right? The center of the circle, C3 somewhere over here. Now we have to find out the equation of the common tangent which is passing through C1 and C3. Okay, circle of C3, something like this, and it is not passing through C2. So that is the equation of the tangent. So this is what we have to find it out. So this line equation is basically this particular line T. Okay, that we have to find it out. So how are we going to solve this problem? Let us try to understand. Right. So this is again a question of family of circles. What we can observe is that, so the equation, so what I can try to do over here is that, now if these two are the point of contact of this particular circle C3, then I can generate any sort of possibles of circle C3 with the, as considering as this particular line and also the circle passing the diametrically opposite point C1 C2, then I can generate the family of circles as follows. That will be basically x minus 1 into x minus 0 plus y minus 1 into y minus 0, sorry, y minus 0 into y minus 0 plus lambda times the equation of the line C1 C2, that is lambda times of xy1, and that should be 0 0 1 and 1 0 1, and that should be equal to 0, right? So from here we'll obtain the equation of this circle or the family of circle in some parameter like this, right? X square plus y square minus x plus lambda times of y should be equals to 0, right? So this should be equals to 0. So this will be the equation of the family of any such circle which is passing to this point of which is passing to this C1 and C2, right? Now since it is said that the circle with the center C3 or the circle passing to C1 and C2 is also having this radius equals to 1, so from here the radius should be equals to 1. From here we can easily find out the value of the lambda, right? So if we do that, the 1 is should be equals to 1 by 4 plus lambda square by 4, and so from here we'll get the value of lambda as plus or minus root of 3. So we will get the value of lambda as plus or minus root of 3, right? So once we get the value of lambda, we have already obtained the equation of the circle C3, but we have to also make sure that the centroid of the C3 is basically above the x-axis. So that will determine that the plus value or the negative value of this lambda should be taken or not, right? So if we take this, so as the center of C3 lies above x-axis, so if we take lambda is equal to minus root 3, then only this particular equation is going to be satisfied, right? So plus root 3 won't be the solution, okay? So this will be not the solution since the center lies above the x-axis. Okay, since the center lies or lie above the x-axis, so this lambda value should be negative of root 3. Now once we get the value of lambda as negative root 3, we can formulate the equation of circle passing through this C1 C2 point, that is x square plus y square minus x minus root 3y should be equals to 0, right? So we have already found out the equation of this family of circles C3s, right? So now we have to find out the equation of the common tangent passing through C1 and C3 and not passing through C2, right? So that will be obtained as, so C1 and C2, so C1 and C3 intersect and are at unit radius, so the common tangents are parallel to the line joining. So since we can observe over here, since these two intersects and also this tangent or the common tangent will be definitely parallel to this C1 and C3 line, right? So we have already obtained C3, right? That is basically 1 by 2 comma root 3 by 2, right? That is what the C3 coordinates are. So this particular tangent or the common tangent should be parallel to this particular C1 C3. So therefore in that particular notation we can all easily obtain the slope of this tangent, which will be equal to slope of this line C1 C3, right? And that should be equals to root 3. That should be equals to root 3. So from here we can formulate the equation of the tangent. Now we also need one point in the tangent that can be obtained as the foot of perpendicular from the center to this particular line, right? So from there, and that particular distance should be also equal to the unit radius, that is 1. So if I do that, so let us assume the equation of this common tangent as root 3 minus x should be equals to or plus k, because that is basically variable parameter, and that will be obtained once we get any point on this line, right? So if I consider this common tangent equation as something as root 3x minus y plus k equals to 0, and the center to this particular line distance should be equals to the radius, that is unit radius 1. So if I do that, I will get the value as k upon root 3, it should be value of k by 2 should be equals to 1. So from here I'll get, so I will definitely need to put a mod. So mod of k by 2 equal to 1. So k should be equals to plus of 2. So k should be equals to plus or minus 2. So from the figure it can be easily interpreted that if I take k is equal to plus 2, if I take the value of k equal to plus 2, it is going to be this particular line, and similarly if I take k is equal to minus 2, it is something like this, okay, something like this, which is passing this C2. So that I cannot take. So I can only take this when the value of k should be equals to 2. Okay, I hope this is clear. So therefore from here we'll get the equation of the common tangent as root 3 minus of y plus of 2 should be equals to 0, right? So this is the equation of the common tangent. I hope this is clear to all of you. I hope this is clear to all of you. Is this part clear? Is this part clear to all of you? Alright, so with this we have wrapped up our entire idea. Y minus root 3, okay, please look it again, the cinema guy, why it is minus root 3. So I have already explained, if I put plus of root 3, then the center of this circle C3 will be basically 1 by 2 comma minus root 3 by 2, right? So that cannot be possible, because I have already mentioned a circle C3, that the center of the circle C3, over here it is mentioned carefully that the center of this circle C3 having its center above the x-axis. So I have to take the value of this center y coordinate to be positive, right? So that is only possible when I take the value of lambda to be negative root 3. Is this part clear, cinema guy? Alright, so please carefully observe the statement of the question. So depending on the question, we have chose the value of this lambda to be negative root 3. Okay, so that is all what you need to recollect and understand in this particular problem. Okay, so I hope this question is clear to all of you. Great, great. Alright, so with this we have entirely finished our entire discussion on this chapter of circles, right? So now our next topic is going to start with parabola. So in this next lecture, what we're going to start with, we are going to definitely start discussing about parabolas, right? So I hope you are able to understand this particular content and you are able to prepare for your upcoming JEE Mains examination, right? So we have been done with straight lines and circles, and our next three topics is going to be parabola, ellipse and hyperbola, and with that we'll be ending this entire coordinate geometry, right? So once we are done with this coordinate geometry, I am going to definitely start with these contents of algebra, right? Is this clear to all of you? Is this part clear? Do let me know if you have any questions, any confusion, or else we shall end this particular lecture, right? So I thank all of you for your attention, and I wish you all the best, and I hope to see you soon in our next live class. Thank you and wish you all the best. I will be there because I need to revise. Cinema guy, great, great. I hope to see you. Right, okay.